Howdy, everyone. So I'm going to go ahead and walk through our Wumpus World project from myself and Naima. On the left, we're going to walk through some of the code on the slides, and then I'm going to go ahead and do a demo as we go through this as well. So very first thing is our environment looks like this. It's a little bit different from the rest of the groups. We have pits at 2-2, 1-3, and 4-4. Our Wumpus is at 3-3, and we have our gold at 3-4. So let me go ahead and show you in Prolog. So I'm going to go ahead and initialize our world first. So we've initialized our world, and we can check to see where our agent starts by getting our current position. So our current position is 1-1. So let's go ahead and just, I guess, start moving, right? Sorry, I made a mistake and pushed enter again. Let me do it again. There we go. So we move to the adjacent cell, and we can see that these are the following precepts we find when we move into a cell. If the cell's unsafe, our move algorithm doesn't allow us to move there, similar to what we've seen some of the other groups do. So there's a pit at 2-2, we try to move there, and it did not work. We also can't move to diagonal cells, and we can see that this destination is not adjacent, so we again get false. Now, we could just move and like learn as we go along what the everything looks like, but we made a few ways to understand what the environment's like. So one, we have a kind of testing way. So this isn't the agent knowing, but rather we can just figure out for testing purposes if the map generated correctly. So we can stimulate the precepts at any location. So let's say 2-3. And this works still because it's not the agent actually, even though it's not an adjacent cell or the cell that we're in. And we get a prompt, like remember to say this, and we say yes. And yeah, we can see that in 2-3, we have these precepts. If we want our agent to understand if there's a cell that's safe next to it, what it can do is it can check the details of a specific cell next to it. So we do a check cell. And right now our agent is in 2-1. So let's go ahead and check cell for 3-1. And boom, look at this. We got a huge listing. We did not visit this safe. We did not visit this cell. It says it's safe. With possible Wumpus, yes. Possible pit, yes. No stench, no breeze, and no glitter. So it's saying safe because there's a slight error there, but we know that it's still safe based off of what our environment looks like. So we can try moving there, and if this is not safe, we won't be able to move there. And we move there, and we're good. Let's go ahead and check our adjacent cell again. And again, we see that it's not possible to Wumpus, not possible to get a pit, stench, yes, breeze, yes, no glitter, right? So let's go to move there. And we move there and we get the precepts again. Now we know that Wumpus is in 3-3, but we can check the cell again to make sure. And what we see is it says it's a possible Wumpus. So we want to confirm that the Wumpuses might be there. And we've implemented a different approach to finding out where the Wumpus is and keeping track of our safe cells and whatnot. So we can do listing Wumpus, and we can now know that the Wumpus is at 3-3. So we're in the adjacent cell, so let's go and shoot to kill the Wumpus. And we shot and we killed Wumpus. We also have a automated move approach, which we can, the algorithm will just go and pick a cell that might be safe and try to move there. So let's go ahead and use that. And wow, we've moved to 3-3. It shows one of the directions it can move in. The one thing is it doesn't go back to visited cells, so you always kind of go through, and that's what makes it a little bit unsafe because it won't be able to move anymore if there's no cells that are unvisited and if they're not safe. Okay, let's go ahead and finish the game off. So we'll move to 3-4. We see that there's glitter here, so let's go ahead and grab the gold. Grab the gold. And now let's go ahead and move all the way back to our starting location quickly. Mm. Anytime we make a typo like this, that's similar. We won't get a yes or no to correction it. All right, and we've moved back to the starting position. So we're going to go ahead and climb out and see if we won. And we climbed out and we safely won. Okay, I'm going to go quickly through a little bit of the code, and then Naima will cover the rest. So first we have our some of our precepts explicitly stated where they are, and they're dynamic. So they'll change, the state will change while the agent interacts with the world. And these are precepts and where the gold is and what glitter and whatnot. Here's where the initialized world, where we put down each of the pits and the gold. And we're asserting all these. We retract it first and then we assert it in the initialize procedure. So we have some adjacency rules. And this is a little bit not propositional. The stuff we've seen before is basically all propositional logic. But when we're doing adjacent cells, we did have to use some predicate logic. And we have our adjacency rules to stimulate the precepts and figure out the whole map, basically, even though we're not there. And this is just kind of for testing purposes. Our inference rules, we infer safe cells, which we saw here, and we can check to see if there might be a safe cells, and we mark them as the safe cells. And we have possible telling where if the Wumpus is there or if there's a pit there. We also did this check cell program that Naima will cover, which also tells us the same things. Okay, I'm going to go ahead and cut it off there, and Naima will cover the rest.
Here for the agent actions, we have the predicate, which is move, that takes the argument, which is new position. And we will see here that there is a current position that captures the location of an agent, and through this variable, which is current. And then this will check the adjacency of the current position with the new position. And if these two cell positions are adjacent, then this will move towards this statement. Otherwise, this will print the message, which is move field destination is not adjacent. So after checking the condition, if the both cells are adjacent, then this will check either these this new position as safe or not. So if the condition becomes true, this will move towards the statement retract. Otherwise, this will print the message that destination is not safe, move field. So let's suppose this safe condition is true after checking the adjacency of the cells, then this will retract the previous fact from the knowledge base, which means remove the fact, and then mark visited. But before marking the visited for the new position, this will assert the new position as a current position in the knowledge base. And after that, here is a simulate precept predicate that takes this new position, and this predicate will check the environment, whether there is a stench, breeze, or glitter. And then this will print this message, move to the new position. Here you can see in this output window on the right side that shows that we have moved the agent to the 2, 1 coordinate, and this shows the perception based on that, and then this has safely moved to the 2, 1 coordinate. And there is the move to save predicate that has no argument. So this will capture the agent's current location and find all the location through this next um, variable, and then and find all the location that meets these three conditions, that is adjacency of this current with the new one, and and to check if the cell is safe, and also if that is not visited before. So all these information are stored in the save cell, which is a list. We are taking this as a list, and then we will check through the condition if this list has some location of the cell, means that if this list is not empty, so this will move towards this statement, and this will work accordingly, and we'll take the agent to the particular location. And here, if you see here, then you can see here that this is the pattern matching concept in the Prolog. Here next is the first element, and this is the constructor operator, and the sign which is next to the pipe sign, that is the um, that is like underscore. This shows the anonymous variable, which means there are rest of the elements in the list. So this will check all the location, all the cells, and to the list. And if this is not empty, then this will move toward the statement, which I already mentioned above. And then if that is empty, if the list saved cells is empty, then this will print a message that no saved cells to move to. Okay, for grabbing the gourd and shooting an arrow, we have the grab predicate here. And this will capture the current position of the agent in the POS variable. And then this will check if this current position has the gold or not. If this has the gold, then this will retract again, remove the fact from the knowledge base that is related to the gold position, and then assert with the one that we have found in the new position. And this will print the message that we have grabbed the gold. And then if the condition is false, like if we did not find the gold in the position of the agent, then this will print the message that no gold is here to grab. And for a shoot, as we know, the cell must be adjacent to the Wumpus cell. So first this will check if this has the arrow, if the cell has the arrow, and if the condition becomes true, then this will remove the fact again related to the arrow from the knowledge base, because this time this is consuming the arrow for the Wumpus, and then this will check the condition, which is capturing the position of the agent, and then checks if the position is the adjacent to the Wumpus position, which is our condition in terms of the arrow, and then also checks if the Wumpus is the same as it must be, like we have um, introduced the Wumpus in 3-3 cell. So if the Wumpus is in the same cell that we have defined, if the condition becomes true, then we say that um, remove the bumpers because we found a bumpers from the knowledge base, remove that fact, and then shot an arrow and kill the bumpers. But if the condition becomes false, then this message will print that we have missed the bumpers because the cell is not adjacent to the bumpers position. So maybe that is next to the adjacent cell. And here for the climb, we have the requirements, which is true that the first one is that the current position must be 1-1, and there must be a gold. Then you can grab that and fly it, or you can win. If no, if you don't have a gold and the current position is not 1-1, then you cannot win the game. Okay. So here is the outcome. You can see here that is related to the current position. We are taking the current position, which shows the 1-1, and then we call the climb function, which is false because we did not achieve the gold in this case. It is very important to display the status of the cells, either that is visited or not, say if there is a Wumpus, stench, breeze, glitter, etc. So all these status are checked and message are printed accordingly through this predicate. Here, this is the check cell predicate that takes the argument x and y, and this checks accordingly. If this xy coordinate is passed through the visited predicate, then this will again checked with the one that we have mentioned in our knowledge base. And same is the case, this will be checked against this save predicate and the Wumpus possible, pit possible, stench, breeze, glitter, which uh, Madhav have explained in the previous slides. So these all predicates will be checked accordingly and the message will be printed accordingly. So this is very useful um, because this shows the status, and here you can see when we have passed the 2, 3 coordinate in these is safe predicate, and this shows that this might be safe based uh, on the check cell predicate, and then this shows the complete status because we have passed the 2, 3, and this shows if this is visited or not. But according to the 2, 3 cell, as per our environment of the Wumpus game, there is a stench and there is a praise. So this is very important for the game environment. To grab the gold, here we have the current position that is 1, 1, and then we are simulating the perception of the cell, which shows this that there is a breeze in the 2, 1 coordinates. Then we are checking. Uh, um, After simulation, we are planning to move to the 2, 1 because that is safe and there is just a breeze. But next to the breeze is a pit, so we will step accordingly. Then we have checked and planned to move towards the 2-2 coordinate, but that is not safe because there is a pit. Then we simulate the next coordinate cell, and that is 3-1, which is safe because there is no stench phase in the glitter. Then we simulate the 3-2 cell which has a breeze stench because in the 3-3 position there is a Wumpus, so there must be the stench in 3-2 coordinates. But there's no glitter because glitter is on the cell 3-4 coordinates according to our game. And but once we have moved towards the 3-2 position, as this is adjacent to the Wumpus cell, so we can shoot uh, and kill the Wumpus, which is true. After killing the Wumpus, we successfully reach the cell 3-3, and then we can move towards the 3-4 to grab the gold. And here we grab the gold. There are some queries that can be used to check the status, to check the functionality of the Wumpus game, which we have designed. I hope you like this. You like our presentation.